You searched PLC with example because you wanted something real, not another lecture. So here is a real PLC program. A start button, a stop button, a motor that comes on with one press and stays on after the button is released. It is the first proper ladder rung every controls engineer writes, and the foundation of every machine that latches on from a single press. It is called a sealin. Here's how it works. Two vertical yellow lines. Imagine them as the power rails of an electrical panel. The one on the left is connected to a power supply. The one on the right is neutral. Current wants to flow from left to right across any horizontal rung between them, but only if every component on that rung lets it through. On the left side of the rung, the start contact slides in. In ladder logic, a contact is drawn as two short vertical lines facing each other, a stylized switch. This one is labeled start because it is wired to a real start button out in the panel. When the button is unpressed, the contact is open and no current passes. When someone pushes the button, the contact closes and current is allowed through. On the right side of the rung, the motor coil appears. A coil in ladder logic is drawn as two curved arcs facing each other, a symbol borrowed from the shape of a real solenoid. When current makes it all the way across the rung and into the coil energizes and the motor turns on. Right now, though, the start contact is still open, so no current reaches the coil. The motor is off. Then somebody presses the start button. The contact closes. Current flows from the left rail, through the contact, into the coil. The coil glows yellow on the screen. That is the visual cue that it is energized. The motor is now running. Exactly what you would expect from a doorbell. Press the button, the thing turns on. But here's the problem. The start button is momentary. The second the operator lets go, an internal spring pushes the button back, and the contact pops open again. The current stops, the coil drops, the motor turns off. The motor only runs while someone is physically holding the button down. That is not what you want. You want one press to latch the motor on. This is where the sealin pattern comes in. A second horizontal branch appears below the start contact, in parallel with it. On that lower branch sits another contact, but this one is labeled motor. It does not refer to the physical motor itself. It refers to the coil's own state. Whenever the motor coil is energized, this motor contact closes. Whenever the coil is de-energized, the motor contact opens. So now read the rung from left to right. Current can pass if the start contact is closed, or if the motor contact is closed. The instant someone presses the start button and the coil energizes, the motor contact closes right behind it. From that moment, the sealin branch is holding the rung true on its own. The operator can let go of the start button. The motor keeps running because the rung is sealing itself in. That leaves one question. How do we turn it off? A stop contact appears at the end of the rung, in series with everything else. This one has a diagonal line drawn through it. That means it is normally closed. In normal running, the contact is closed and current passes straight through. The moment someone presses the stop button in the panel, the contact opens, the rung is broken, the coil drops, and the motor stops. Watch the whole cycle play out. The start button is pressed. The start contact closes. Current flows. The coil energizes. The motor turns on. The start button is released. The rung does not break because the motor contact has already latched closed underneath. The sealin branch is now holding the rung. The motor stays on. The stop button is pressed. The normally closed stop contact opens. Both parallel branches lose their path to the coil. The coil drops. The motor stops. The stop button is released. The stop contact closes again, but the motor is already off, and the motor contact in the sealin branch is open. The rung stays broken. The motor does not restart on its own. To turn it back on, somebody has to press the start button again. One press of start latches the motor on. One press of stop latches it off. One rung. 3 contacts. One coil. That is the pattern running tens of thousands of conveyor motors, pump motors, and fan motors right now, in factories all over the world. You can build this yourself, right now, in your browser. The lesson is at plcsimulationsoftware.com. Try the latching and sealing in lesson and run it. Next video, how to become a PLC technician in 2026. The certifications that get you hired, what employers want, and the free preparation path. See you there.